Okay, so here we have a chart showing you some examples of hydrocarbons. So aliphatic, remember, can be alkane, alkene, or alkyne. Aromatic has a benzene ring. Okay, so these are just showing you a couple of examples. So start to recognize the portions of the name that are familiar. So for example, notice this alkane, ethane, has an ane ending. Okay, so any alkane will end with the same suffix, ane. So eth, which we'll get to in a second, but eth corresponds to the number 2. So ethane means that there are 2 carbons and they are single bonded. So the nomenclature that we're going to be looking at here is very different from nomenclature we've done in chemistry in the past. It's almost like you're learning a new way of doing things, a new language. So there's a few ways of showing this. So they're giving you the formula, of course, which we recognize. A space-filled diagram is just kind of showing you the sizing that this would take up. So the little white domes are representing your hydrogens, and then the grayish dome is representing like a carbon atom. Okay, so over here we have carbons, and then so this is sometimes referred to as like a ball and stick model. So it's like as if you were using spherical particles to represent atoms. Okay. Cyclohexane. So let's take a look at this. So cyclo, the prefix cyclo refers to something that is a cyclic formation, like I mentioned. So notice all of these carbons are interconnected. Now, the hex part, hexane, or think of anything that has a prefix hex, represents 6. So cyclohex means that you have a cyclic formation with 6 carbons, and the ending again is ane because they are all single bonds. So altogether, this is cyclohexane, which means it's a cyclic 6-bond single covalent bond structure. Alkene. So now you'll notice the ending, if it's an alkene, is ene. So ethene means 2 carbons, just like it did up here. The eth means 2, and the ene means there is a double bond between the 2 carbons. An alkyne, the yne ending, ethine, yne. So again, 2 carbons because of the eth, and then the yne means that there is a triple bond. And of course, benzene, we have seen this structure already. So notice the difference. A lot of the time there's a big mix-up between cyclohexane and benzene. So they're sort of similar because they have 6 carbons in the cyclic formation. But remember that what makes benzene unique are those alternating double bonds. Cyclohexane does not have a double bond at all. So just be wary when you're looking at that and you're looking at the structures. Okay, so I've mentioned this already, but hydrocarbons, especially aliphatic, can come in either a straight chain, a branch chain, or a cyclic structure. So we're going to start referring to these things called branches. Okay, so let's see if we can do this here. So when you are looking at a molecule, especially if it's a straight chain, okay, this would be referred to as a parent group. So a parent group is like the main chain in your structure. So what a branch is, I'll show you. So let me fill this all in with my hydrogen. So remember, your tick lines are representing hydrogens here. Okay. So in this case, how you identify a branch from a parent is the parent chain has to be the longest continuous chain of carbons. So for example, here I have 1, 2, 3, 4, 5, 6. Now, you have to basically, when you're looking at a structure, figure out the different ways that carbons are strung together. So for example, another chain could be 1, 2, 3, 4. So if I were to look at this is still smaller than my 6 in a row here. So Another way, the last way we could do this would be 1, 2, 3, 4, 5. So it's still not long enough in comparison to the 6. So the parent, in this case, would be my 6 carbons, and anything that is coming off of the parent is considered to be a branch. So this single carbon here, because it's not part of that main 6, is a branch. So branches have a different way of being named. So branches are considered to be, sorry about that, an alkyl group. So when you have a branch, we don't just call it, let's say, ethane. The ethane, so going back to this is the parent name. The A-N-E ending is for the main parent. As soon as you have a branch, you now have the ending of YL. So alkyl ends in YL, so does the branch. So a methane group, so 1 carbon is actually the prefix of meth. So 2 carbons is eth, 1 carbon is meth. So if it's a branch, it would actually be called a methyl group. So over here, the one we just drew, this is a methyl because it's a branch that's made up of 1 carbon. Okay, so as I mentioned, we've already talked about the shapes, but when you have carbons that are making all 4 sigma bonds, we know we have a tetrahedral shape. So there's a whole bunch of different ways that we can draw and represent molecules. So we can use a space-filled model. Okay, so that's something like this. Okay, I'm never going to expect you to draw that. But when you're looking at it, just so you understand what it is. Structural formula means that you are writing out the formula, right? So for example, something like this, CH2, CH2, right? That's a structural formula. You can also use carbon skeletons, as I mentioned, which I've been showing you with the lines, or you can use a cyclic shape. So what that means is, for the cyclic shape, let me get a color here. So let's say I had 3 carbons that were in a cyclic form, like this. So remember, each one of these has their hydrogens. Okay, so instead of drawing this all out, you can actually just use a carbon skeleton form of that shape. So for example, remember each point represents a carbon. So this is carbon, 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 carbon. So this means exactly the same as just simply drawing the shape of it. Okay, so like I said, this will get easier over time. So actually, since I have this example up here, if we were to compare this to what it would be in a carbon skeleton, so it's 6, 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. And on carbon 3, there's a methyl group. So on carbon 3, you would just draw a line. Because remember, the end point on that line is representing 1 carbon. So this is the same thing as this right here. Okay, it will come, I promise. Okay, so here's an example of each one of these. So technically, this carbon skeleton is showing you with the hydrogens. A true skeleton is just showing the carbons. So don't just kind of take this with, this is just showing you an example. Instead of having the formulas written out as CH3, it's literally showing you the connection of C with the 3 H's. Okay, so space-filled model, structural formula, carbon skeleton, which can be pared down even more. And then, of course, we can use a shape for something that is cyclic. So this is cyclo, 6, hex, and they're all single bonds, so it is ane. Okay, so like I mentioned, the nomenclature here is going to be very different than nomenclature we've done before. It's almost like you're writing out a map. Each prefix, each suffix, each term or part of a term represents something about that structure. So it could be the number of carbon atoms, it could be the type of functional group it is, it could be where on the molecule a functional group is, right? So we're going to start determining the location of them. So it will be a very different set of rules that you're used to. So just like with everything else, chemicals can sometimes go by common names, right? So we know, for example, water is H2O, right? So water technically is dihydrogen monoxide. Okay, that's the proper IUPAC term. But we don't say that. We say the common term of water. So it's the same deal with organic compounds. We can have a proper IUPAC name, okay, which is what I'm going to be teaching you this semester. Um, or you can have a common name. So very often the IUPAC name for organic molecules is incredibly complex. The bigger the molecule, the more complex the structure tends to be. So something like ibuprofen, which I'm sure a lot of you have heard of before, right? So it's just an over-the-counter pain medication. This is the structure, right? Here's the IUPAC name, 2,4,2-methyl-propyl-phenylpropanoic acid. So it gets more and more complex. So of course, you're going to be learning how to do this, what each of these terms mean, and how to string that together by the end of the unit. All right, so we're starting with simple straight chain alkanes. So remember, an alkane, the ANE indicates that they are single covalent bonds. So the suffix has to have the ANE. Now, before you do anything, you need to determine your longest straight chain, or I should say interlocking carbon atoms. The longest chain is your parent group or your parent chain. Any of the branches have the suffix of YL. So if it's a two-chain branch, it would be an ethyl group. Okay, so I've been saying things like meth and eth and hex. So this is just to let you know what the names are depending on the number of carbon atoms. So 1 is meth, 2 is eth. So notice it says methane, right? Only single bonds. Ethane, single bonds. Propane. So prop, the prefix prop represents 3. The prefix bute, so like butane, represents 4. After bute, all of the rest of them correspond to the Greek prefixes that we know from math and from when we do molecular naming. So for example, pentane, right? A pentagon has 5 points or 5 sides. Pent means 5 carbons. Hex, hept is 7, oct is 8, non, so nonane is 9, decane, so dec is 10. Okay, we're not going to be going beyond 10 here. And just a little helpful thing to have you remember the order of the first 4. Okay, I'm assuming you guys know from Pent on. So monkeys eat peeled bananas. So meth, eth, prop, bute. Okay, so 1, 2, 3, 4. Okay, so the first thing you're going to do, oh my goodness, I have a typo. Sorry about that. So the first thing you're going to do when you get a diagram or a structure, you're going to identify the longest continuous chain. That's the parent chain. I've already mentioned that. You're then going to look to see what branches you have, and we're going to name the branches with the YL ending. Now, the order we write the branch names are going to be in alphabetical order. Okay, you'll see we'll be doing a bunch of examples. You're going to then use a number to say where on that branch, or I should say where on the parent chain is that branch located. We always want the lowest possible numbers. Okay, so this may not make a whole lot of sense. It will once we start doing some examples together.